Okay, let's get this underway. Hi. No, I'm in a different setup than I was last time, so I want to verify, first of all, can you all see and hear me okay? Just type in chat if you can see me fine. Awesome. Cool. So, hello again. My name is Michael Gussert. I do a little bit of everything on IsaacSim. I don't really know what they keep me around for, but apparently right now it's to do live streams. I'm currently traveling. I'm in Wisconsin visiting my family, and I thought that this would be a good opportunity to go over how we can do work in the cloud with IsaacSim. And this is going to be another one of those instances of me kind of peeling back my kimono of ignorance and revealing the lack of understanding I have for some of these systems. But we're going to take it one step at a time, and hopefully we can learn something useful. So to start with, I am basically going to be following the tutorial that you currently see on the stream. So I'll swap to here. And I'm going to paste this in chat as well. So if you want to follow along, you can. There we go. So to begin with, you're going to have access to an AWS account. AWS is it's Amazon's online cloud compute platform. And it's extensive. There's a reason why there's an entire career field called DevOps that's dedicated to just understanding and figuring out how to launch and manage virtual instances on this system. And the tutorial that we're going to be going over today is going to show us how to set up one of these instances on AWS. We're then going to pull a container for IsaacSim. And then with that container, we're going to launch training with Omni Isaac Gym environments. And we're going to hope that everything works just as well as it did the last time I tried this. So to begin, the first thing you're going to have to do is you're going to have to generate a key pair PEM file. So we're going to be predominantly accessing the cluster through SSH, at least for setup. And to do that, we need to be able to securely access that machine. And we do that through these specific key files called .pems, which I probably should have looked up what that acronym stands for to begin with. But so to start, we're going to go over to keys on the left-hand side, key pairs. And these are all of the different keys that have already been generated. So I'm on NVIDIA's, we have an account with AWS, so I'm on that account. So there are keys here that I didn't create, but the ones at the bottom are labeled right here. So we can create a new one to test. So you can put any name you want here. So live stream test key. And we're going to choose RSA encryption. We're going to switch this over to a .pem file, and that's basically it. This is going to give you an option to download this test key, this key file. And this is your only opportunity to download this file. And you're going to want to save it wherever you're going to be accessing the cluster most, right? So I already have this set up in a directory with the Bayaki key file here. So if we go into live stream, we can see that I already moved the .pem file from before into this directory. So we already have a key file pair generated for this purpose. But you're going to want to put this somewhere where you can easily access it because you're going to be using it directly in your SSH command line. And that's a way of interfacing with SSH that I've never actually done before. This idea of it's very complex. And sorry, I'm not answering questions immediately because I only have one screen right now and I'm swapping back and forth. Privacy enhanced mail. Maybe. Sounds reasonable to me. But I'm not confident enough to say that that's what it is for sure. But anyway, so let's just say we already have our key value pair generated, and you have it saved somewhere ready to go. We're now going to go over to instances on EC2. EC2 stands for Elastic Cloud Computing, or Elastic Compute something. It's the acronym that describes the system of dynamically creating virtual machines, launching containers on those machines, and then doing stuff and serving data from that virtual instance. That elastic structure of being able to add and remove things at will and have it be stable, that's all under this EC2 acronym. And so we're going to create an instance that's going to launch, I guess, on EC2. And I have a pre-bake here, but we're going to make a new one. So to start with, you're going to go to Launch Instances. And then, again, we can call this whatever we want. So we're going to call this Live. What? Why no typey? You know, of course, there we are. Right. So again, this can be any name that you want. And we're going to choose an Amazon machine image. So these are, I don't know if they're Docker containers, but they're virtual machines where we specified the specific kind of hardware that it's going to have access to, the specific drivers, and the operating system, I believe. And so in this case, we're going to use our AMI. So we're just going to search here for NVIDIA Omniverse and hit enter. Hope. Yeah, awesome. So you should see it under the AWS Marketplace AMIs. It's this one right here. And we're going to select this instance, this AMI. This gives you the price per hour for where you've set your location to be. So we have multiple different the terms to use here. We have multiple different, I guess, places we could be accessing this cloud instance from. You want to pick one that's close to your actual geographic location. Mine's defaulting to Oregon because that's where I came from. But so we're going to pick this one. And then that's going to load in here. I'm just going to make sure that that actually loads. And while it does, I'm going to go back and look at questions. All right. Cool. So we've selected our AMI. And now we're going to pick our instance type. Now, there's a really cool tool that Papa Chuck, who is a member of our community, who I was originally going to do this live stream with. We got big plans for another one later for that one. But anyway, he introduced me to this really excellent tool that shows you all of the metadata about the various instances that are available on Amazon's EC2. So you can go through here and you can literally, like, these are all the different types of physical hardware machines that we can launch our instance from. And specifically, we're going to be using the G5. Why do you do that? No. Why did that happen? That's not what I wanted to do. Totally just singing random songs to alleviate my anxiety about doing this live. Cool. So we can look at all of these different machines and see what kinds of capabilities we have. We just pick one at random. Let's look at this M6ID double large. I have no idea what this is. So this is a looks like this is a purely CPU-based instance, for example, and you can see all the different metadata attached to this instance. So in here, where you're picking what you want. You see the default here is G5.2x large. Like, what even is that? What does that mean, right? So you can go to this website, this instancesvantage.sh, which I should paste in the chat right here. Oh, already done for me. Cool, thank you. And we're gonna look for G5. So we're gonna search explicitly for G5 right here. And we want the G5 2x large, that's this guy here. And we can see that on the EC2, we see it says 8 virtual CPUs, 32 gigabytes of memory, and we can confirm here that we have 32 gigabytes of memory, 8 virtual CPUs. So this is that machine. We can get all of our information that we might want to know about it from here. So we're going to pick that one. And then we're going to go down to our key pair login. So we could pick the livestream test key, but since I don't want to download and move it somewhere, I'm just going to use the BIOKey key. And then we're going to go into our network settings, and this is important. So this is how you're going to restrict access to your instance. So suppose you have an AI model that you've trained already, and you have it on in a container on an AMI, and you're serving data to and from that agent, right? You want to send it up inputs, have it do the thing, and then send you back your results. You want to make sure that if you're serving that model, that the kind of traffic that's accessing the instance is only the kind of traffic that you want. Because if you open it up to everyone, you're going to open it up to security threats, right? So because we're doing a demonstration and we're just doing training, we're going to set this up for all traffic. So this means that all traffic that's going in and out of our instance is what we're going to be concerned about. And we're only going to accept traffic from my current IP address, which is, I guess for me, technically I'm on VPN, so it's static right now. It's going to be the same as it was last time. If it wasn't, I'm going to have to fix that. But this should be just it should just be an IPv4. But you want it from just your IP, and then we're going to, I think it's create key pair, security group rule. No, we don't want that. So this is already configured. So now we go on to storage. Now your default free instance is going to come with 30 gigabytes. And unfortunately, for the stuff that we're going to do today, I don't think that's actually enough. When I tried to extract the container using our default, the default amount of memory that was allocated, I ran out. So I increased this to about 100 for this demonstration. And then you go to launch instance. And the EC2 is going to take all your configuration. It's going to go find that specific machine. It's going to launch the virtual machine, and then it's going to return us to the instance page so we can connect to it. So while that's going, I'll swap back and check for questions. Are there any different prices for different regions? Maybe I would pick one based on that. That's a good question. I'm not entirely sure. Price seems to be predominantly dictated by the hardware, right? There's a lot of demand for high-end compute, GPU systems. And so I expect the price is dictated predominantly by that demand. But I'm not certain off the top of my head. Oh, and it looks like it's done. So let's swap back to the other screen. And we can go over back into our instances, right? And now we see that the live stream instance, this very live instance, is currently running, right? So if we want to connect to it, we're going to connect via SSH. So we're going to select this instance, and then we're going to go to connect, and we're going to select the SSH client, and we're just going to copy that command. And now we're going to go back into live stream, and we're going to paste in this command. I'm going to paste in this command. Oh God, come on. We're going to paste in this command. Thank you. And you're going to have to change this default here from root. And for this instance, I think it's an Ubuntu. Ubuntu instance, right? It's going to ask you if this is what you want. Perfect. So now we're on our virtual machine, which is located in the cloud. And we want to be able to run IsaacSim on this machine. So the first thing that we need to do is pull and install the IsaacSim container. So this is a Docker file, a Docker container that we created specifically for IsaacSim. And you can, in the tutorial, they ask you to check this out. I actually like doing this too. You can use NVIDIA SMI to actually see what is running on the instance. So when this runs any time now, perfect. We can see that we're on an A10G, which is what we expected from this 2x large, right? And we want this here. You can't see my console. You can only see my Chrome window. I need to change what I'm streaming. So stop sharing that and then start sharing everything. I'm sure it won't end horribly for anyone. It's going to be just fine. All right, now you should be able to see the terminal. Oh God, infinite stream. Yes, perfect. Let's just get out of here again. Awesome. So the terminal commands that I ran here, I ran NVIDIA SMI to view the details about the GPU that's actually on the machine. And now we're going to pull the containers. We're going to do Docker pull, and then we're on the public ECR, AWS, NVIDIA, IsaacSim. We want 2022.2.1. Yes. And then this will pull and extract the container to this instance. And this is going to take like 5 minutes, which is why I have the pre-bake instance set up. So if we instead go into here, so while that's doing its thing, I'm just going to go into this other instance. You know, it's kind of like a cooking show. I did this ahead of time. Look, it's all done. I can pull out of the oven. It's instantaneous. It's perfect. Let's just hope it doesn't mess up. So we're going to run this one. So we've stopped this instance ahead of time. So I can right click and I can go to start. Now, when you start an instance running, that's when you're getting most of your charges because you're actually running the instance. But if you stop it and you have storage, your charge, the amount that they charge you, I think, is significantly reduced because you're only paying for the long-term like hard drive space that you're using for that instance. So we're just starting it up, and then terminating an instance means actually removing it entirely, so it doesn't, so you can't use it anymore. So this should be running now. Yes, it is. Perfect. So now I can go to the live stream pre-bake, and I can go to connect. I can go to here, and I can go to there, and then I can go to live stream. Nope, nope, nope. Perfect. Oh, I typed it in wrong every time. Fat fingers, man, it's the worst thing. Ubuntu. Perfect. So this already has the image downloaded. And now we want to do some training, right? So we have our instances, not our instance, our container for IsaacSim has been downloaded. It's not running yet. It's been downloaded. So now we're going to go to GitHub. So this is Omni IsaacGym environments. So this is a repository that contains This is the repository that contains a lot of our preliminary work to set up large scale RL training with IsaacSim. And we have a bunch of pre-made examples that we can launch and play with. But we can also spend some time going through the code if we like to try and figure out how to make our own, which is going to be what a later stream is going to be about. So let me swap back to, I probably didn't have to stop sharing. I probably could have just swapped it to one of those like different, back down the infinite rabbit hole. Okay, so we're gonna pull this, so you can just copy this, right? And then in your cluster, in your machine, you do a, is this done yet? No, it's still going. You would do a git clone, and then the address that they give you, and that's going to give you the Omni Isaac Gym environments directory here. And now with this, we can just launch the IsaacSim container with all of the OIGE stuff pre-set up for us. So we're going to do /docker and then run docker.sh. Oh, I'm so happy. There's some hiccups in the scripts that we're using to launch here. So actually, before I'm done, I wonder if I can share a file directly in chat. If not, I'll figure out a way to post it on the notes for this stream after I do chapters. Or better yet, it'll be updated eventually, and then it won't matter. But there's the current script that's in this repo is assuming that you're pulling the container directly from NVCR instead of AWS. So there's some minor changes in the script to get it working on the cluster, but nothing crazy. Okay, so now that we're in Omni Isaac Gym environments, launching training is as simple as, I say that, of course, and then I immediately forget the command. So it should be IsaacSim python.sh. So the container has IsaacSim installed in the root directory, and we have our own Python there. So we're going to use that to call scripts PTS. And I think it's RL games train. And then I always forget. I think it's yeah, here we are. Task ant headless true livestream true. So the task here, there are a bunch of predefined tasks that are in this repo. So if we go into Omni Isaac Gym environments, we can see under robots and articulation, these are all the different tasks, the robot tasks that we have, or robots that we have for different tasks, right? So ant is just your standard Mujoko ant. So a sphere, 4 legs with 1 joint each, learning to run, which is a pretty good like initial, let's do a sanity check and make sure that this isn't going to break. So what this is going to do is it's going to launch IsaacSim and begin running the training script. And in order to see what's going on, we're going to have to connect to it with our live streaming client. Now, connecting might be problematic if you try and do it immediately after launching, because it takes some time to compile RTX shaders the first time, and the order of operations is different depending on who wrote the script that we're running. So it might not be listening to that port in time for your connection. So I always wait until I start seeing that it's training, and then I connect, because I'm confident that it's going to be it's going to work. So while that's loading, let's answer some more questions. Can post in Discord channel also? Yes, I can. Do you guys have the same VM for Microsoft Azure? That is a good question for my friend Spencer, who I don't know is in chat right now. So Spencer's the guy who heads up all of our Isaac Sim cloud computing stuff. Isaac Sim in the cloud is kind of like his bag, and he would know this better. I don't have a whole lot of experience with Azure, so I don't feel comfortable commenting explicitly on that. Let's see what else. We could run our own Jupyter notebook. Yes, this is also something that can be done. We have a bunch of different ways of interacting with Isaac Sim through Python. We have a Jupyter notebook setup that I got working once, long time ago. I haven't tried it again recently, so I don't know if it's the exact same thing. But there's also an extension called Repel that you can use to attach an active or an interactive Python prompt to a running instance of Isaac Sim. So you could use that to like control with Python from outside of the of Isaac Sim without using the script editor and stuff. Okay, let's see if this is done. Is it done? Is it done? Is it done? It is. All right, so you can see that it's training, right? We have the FPS. We have, I think this is the reward proxy. And then this is our training epoch. So now to actually look at the stream, we're going to use our live streaming client. So if we go over to Omniverse, your Omniverse launcher, and you go into Exchange, do a search for live stream. It's not backspace. Fat fingers. Live stream. Okay. So you search for streaming, and you install this. And what this is going to do is it's going to give you just a little prompt for an IP, right? So it needs an IP address for our machine. So to get that, we're going to go back into our instances, into this screen here. And now we're going to select the instance that we want to connect to. So we're going to select the pre-bake, and we're just going to click on this instance ID. And then down here where it says public IPv4 address, we're just going to copy that. And then we're going to go back into our live streaming client. And we're going to paste that into here. And we can see the ant training. So some things to keep in mind. First of all, perf doesn't look good right now. And it doesn't look good for a lot of reasons. Number one is we're streaming this. So all of the data that we're seeing on this screen is coming from our remote instance through the internet and then rendered on the screen. So there's going to be delay there to begin with. The second thing is that training headless is always going to be faster than training with a rendered image, because there's a lot of time that gets occupied to actually produce that rendering. So if you run training with this live stream command, so if we go back up here to where we launched, no, up to the top, why does it, oh, it's updating there. Now I should pause. So here, where we actually launched the training, okay, I can't get it because it keeps updating. But actually, I'll just copy the command. I'll copy the command from here. This.
Hey, Michael. I wanted to interrupt really quick because this is so fascinating that your screen is not being shared, so they can't see the work you're showing off.
My screen isn't being shared. Ah, crap. Sorry.
Thank you, Zia and the others.
It's a constant struggle.
It's a lot to manage on the screen. So I just want to pop in, really say hi, and
sorry.
The stream's going great though.
Thank you very much for coming to my rescue. Yeah. I really appreciate that.
Anytime. Keep going. Keep the great work coming.
I will. Let's go back to here. So we're sharing the entire screen. We're sharing that. All right. So now to verify, can you guys see this now? The infinite rabbit hole. And then we'll head back. Yeah, okay, cool. So we can go back to here. We want to minimize that. All right. So back in Omni Isaac Gym environment. So if you are training remotely, if you're training in the cloud, if you include this tag, enable live stream equals true, this is just like if you were running without headless mode, right? Because it has to perform that rendering step in order to get that data out of the machine. So you will notice some perf effects by not running in headless mode. And that's another reason why this looks like it's going so slowly. But whoa, we're already getting some really interesting motion. I could do this all day. Anyway, changing the robot that you want to train is as simple as just changing the RL Games what scripts RL Game headless true live stream task equals ant. Why does it say task equals ant? Did I lose something? This should launch Animal, assuming I didn't mess it up, which, you know, there's always a chance. Questions while we wait. Do I do a lot of AI training? Yes, I do. I do a ton of AI training. Most of my work involves designing, training a model, trying to figure out why it's failing, and then updating it. I do a lot of research. I'm very interested in embodied AI and AI safety, and I'm very interested in how we can make more efficient transformers, because there was actually a recent statement that was made, I think it was someone at OpenAI who said something to the effect of that the age of large models is the age of seeing massive improvements just to scaling out and scaling up was coming to an end. Like, we're kind of hitting that plateau. So now it's going to be all about understanding what the models are actually doing and making them more efficient. And yeah, AI safety would be another stream that I'd love to do it. I'd love to present on that, but I got to present on that internally first before I start presenting it to the public. Okay, so yeah, so this is training. So we can go back into here and we can connect again, because that IP won't change, and we should see Animal this time. Perfect. So that's it's really early. Wow, it took way less time than I thought. So that's kind of all I had to show today as far as the live streaming stuff goes. I may want to swap screens. Oh yeah, I did that thing. You're seeing the sorry. When you have two screens and you can just stream one and then have all your other information on the other, but I don't have that here. So that's all I have prepared ahead of time for this live streaming stuff. I want to go over how we actually add a new robot in here, but I want to go over that with Papa Chuck, because he's working on something super cool that I think is going to be worth sharing when it's ready. But the process of adding a new robot to this system is not trivial. And that's something that we're specifically trying to engineer improvements for. We want the process of defining a robot and defining an environment and defining a task in that environment to be three separate things, where the robot itself and the task are completely independent, right? So having an animal wandering around on terrain, what type of terrain it's learning to walk on should be independent of the robot, which should be independent of what the specific task it's trying to perform on that terrain is going to be. And decoupling those different pieces and having them play nicely together is tricky. And it's an ongoing problem that we're trying to figure out. So like I said, I don't have anything else prepared for this stream. So if there are any questions, we can take those, and we can do forum questions or Q&A right now. Stanford has a paper using 2-arm robot that's telepresence for training, so 4 arms in total. Can one build an Isaac Sim twin for such a custom robot, and kind of results we could hope for? There's I think one of my colleagues, can't remember what it's called. Shoot. One of my colleagues, Encore, he did a paper that was a robot telepresence where you could have your hand reach out and like you're grabbing something, then a camera's watching your hand. We translate the hand motion into a model of how the grasp should be done, and then a robot arm with a non-humanoid hand executes the grasp based on what you're doing on the camera. But I can't remember. I want to share that if I can remember. Let me I can ping him. Next question. Is it rewind to repel timestamp? No. Okay. Other questions? If not, we can end the stream early. How does the drone robot work? Which drone robot are you referring to? We have many drone robots. You mean the Crazy Fly? Yeah, okay, so it does need to fight. Actually, that's something fun that we could talk about right now. Let me see if I can't send this to myself somehow. Yes, the Crazy Fly drone needs a flight controller. That is something that it has to have. I'm going to email myself because I've done a bunch of work on this. I just haven't implemented it yet. So let me do this real quick. Compose to myself. Image and then attach. I did a bunch of math to work out a quadratic program, a quadratic flight controller for a quadcopter drone. And I want to find it so I can share it, because if you guys are better at this kind of stuff than I am, it'll be much, much easier than me having to implement it myself. Of course, that relies on me trying to find the image of my whiteboard that I took, and I can't seem to find that. I'll post it later. But yes, we need a drone controller. So the idea that I just want to show, the idea is that if you solve the kinematic equations for a given drone, right? So if you write down the equations of motion, you can define a quadratic optimization problem based on maintaining stability of the drone so that the net torque and the net force acting on the drone is 0. And then once you've defined that QP problem, you can change the constraints in order to make it think that it's not actually stable. And so it'll start flying in a way to make itself stable within this controller. And I did all the math, and I have it on a whiteboard. I just have to send it. So awkward. Oh my God, I hate how awkward this is. It's the worst. The worst. The worst. Images, pictures. Where is it? Photos. Here we are. No, Google, go away. No, Google, go away. Here we go. We want this one. Yeah, this is what we want to send. Share. I want to send that to there. Okay, now I'm not sharing my screen, so you guys can see what I'm doing. So I can go into my email and not have to worry about things being seen that should not be seen. Perfect. View photo. Yes, it's fine. This is so much worse, so much more awkward than I ever imagined. I want to share this because okay, I'm just going to put it on Slack, and then I'll get on Slack and then disable Slack, and then I won't see any of my messages. Okay. Perfect. There we go. Okay. Can I look at this? I can. Perfect. And then I can turn off Slack so that no one sees notifications. And then we can go to here. And then we can go to there, and then we can share. Okay. So, can you see the image on the stream right now? I think so. I think you can. Yes, you can. So what we're looking at here is that QP problem that I was trying to explain. So I modeled the drone as a sphere, and then I said we have four, I called them thrusters, and I didn't fix them in place because I wanted a general solution, right? So we assume that the thrusters can be at, whatever angle relative to some fixed spherical joint. And there are three angles that determine the position of the thruster, but you only really need two. And then you write down the force equations for the net force and the net torque. And then you can rephrase the problem into this quadratic form. Actually, I should share that too. It's a great library, OSQP. This library is just wildly useful. It provides an extremely efficient method for solving QP type problems. And so once you have the math worked out and the equations written down, all you have to do is compose these two like tensors that contain all of the coefficients of these equations in the right order, depending on how you've labeled things. So I think the dimensions that I chose for this, I'm decoupling everything in components of the thrust. So there are for each thruster, there are 3 components that go with it. So there are 12 total dimensions, and then that's just for force, right? There's also for torque. And so you write down all these things, and you're supposed to be able to plug it into OSQP and then hit solve and get the predicted, if I want to go in this direction with this velocity and this angular velocity, where do my thrusters have to be positioned and how much force do they have to emit in order to go in that direction? And then all you have to do is phrase the problem as a stabilization problem. And now going in that direction just means tricking this thing into thinking it's unstable in the opposite direction, and then it flies the way that you want it to. But I haven't gotten it working yet. But if you guys can make heads or tails of this and figure it out, I think that would be awesome, because then we would have a drone controller, right? Which has a whole just smorgasbord of ethical problems that get tied into it with AI, but we're not going to get into that today. Other questions? Can we put that on Jetson? If it works. If you give too much coffee to Gus, he might invent time travel. Other questions? Okay. Well, I think I'm going to end the stream early today. Thank you for tolerating the hiccups that went on with this one. How to sim outdoor environments. I mean, the same way that you sim indoor environments, unfortunately, which means you have to generate the assets, you have to place them. It's just a pain. The real trick, I think, for simulating outdoor scenes is going to come with nerfs and photogrammetry and stuff, right? Because if you're just flying around to learn how to navigate, you don't actually have to have the individual assets in the scene. You just need a three-dimensional representation that you can get info from your sensors, you know? And so you don't have to necessarily have all those messages. Oh yeah, NERFs, neural radiance fields. That's another way of representing a 3D object without having it be a mesh. One question, see above. One question, see above. One question, see above. Would it make sense to use Isaac for this type of work, or is Isaac mostly designed for physical training environments? What is this type of work? Joined late, but customizable, different training tasks. For example, how to have some agents which have their own language models and then figure. So Isaac is really about robotic simulation, right? If you want to simulate a robot performing a task, Isaac is what you want to use. If you're interested in making a training environment for like an LLM or some kind of like a video game controller or a bot or something, Isaac might not be as good a choice because it really is focused on that physical simulation. I hope that helps. Yes, there is. There's something that we're working on. I think it's called, I don't know if I can say it out loud. Let me Google search quick to make sure it's public. Yes. So yes, we can generate procedural environments. We have an extension called Scene Blocks, which uses wave function collapse to generate warehouses is the default that we have set up. But anything that you can create a tileable environment, you should be able to use this same kind of system, probably with a bunch of engineering to get it to give yourself procedural environments. How friendly is Isaac for deformable terrain like sand? Is there any reference model for that? Thanks. Isaac will be in the future very good for deformable environments. Let me see, soft bodies, Isaac Sim. We have some stuff with Isaac Gym, and we're working on getting stuff into Isaac Sim. I am not knowledgeable enough to feel like I can speak with confidence on the status of that. On a local system without an RTX GPU. That's actually, so there's this question here. This is a question that actually came up internally because there's a whole group of people that we have predominantly in Seattle, but also in other parts of the country as well. There's a bunch of different labs, but the one that I work with closely is the Seattle Robotics Lab. And there is interest there in creating a form of Isaac Sim that is effectively just the physics engine and just the interface to the physics engine without rendering. And I can't comment on like how that's going or when that's going to be coming out or if it's going to be coming out, but that is something that we're interested in setting up because that'd be very useful. Sim and Gym, so ideally the technical differences between Sim and Gym is none, but Isaac Sim and Isaac Gym when they started out in development, there were different needs, right? Isaac Jim's need is around parallelization and physically simulating many, many robots and getting that data in to do reinforcement learning. And Isaac Sim was very, very focused on the accurate simulation of a physical scene and communicating with Ross with that simulated scene, for example. And we're moving Isaac Jim into Isaac Sim, and so eventually they'll be the same thing, I think. Don't quote me on that. Will Omniverse come out on Mac OS? I have no idea. Is there a specific time for a future release for deformable terrain? Again, I can't comment on that. I don't know. So as of today, if you don't have an RTX graphics card, cannot spend on a cloud service. There's no way to run Isaac Sim. Unfortunately, I think that is the case. I wish I could give you better news about that, man. I'm sorry. That shouldn't be the case, in my opinion. But then again, I don't know how you can have like a high fidelity robotics simulation without having GPU run physics and rendering. So I don't know. I guess what I'm saying is I feel your pain. I do. Okay, we're down to the last 10 minutes. So let's do 2 more questions tops before we call it. Let's scroll up and see if I missed any while we wait for the counter to go down. One more question above from Sergey. Where is that? Scroll. If I want to add a custom wheeled robot to the environment and train a model with this robot, should I use wheeled robot class as a parent class or robot class as wrappers provided in Isaac Sim? That's a great question. So it depends on the kind of wheeled robot. If you're dealing with a differential base, I think wheeled robot's probably just fine. But if you're doing something with omnidirectional wheels, then you're going to want to use something like the holonomic controller instead. You could start from just the robot base, but you're going to have to do all the mathematics to make sure that the articulations that you define and use in that base are going to give you the results that you want. So I think your best bet's going to be to start with wheeled robot if you're doing just a simple differential base. And anything more complicated than that, you might have to do something custom. Custom sensors, custom sensors is another thing that we're interested in. So recently, we transitioned internally from moving our development branch from Kit 104 to Kit 105. And Kit 105 offers some different functionality when it comes to asynchronous behavior, specifically with our sensor simulation. And I'm hoping, and we're working on, bringing a more robust sensor simulation to Isaac Sim. We also have an omnidirectional base as an extension of wheeled robots. Yes, thank you, Renato. Yeah, so we do have that as well. Okay, one more. Did I miss anything from up above? New comments. Awesome. Okay, well, thank you for listening to me ramble. I hope it was at least entertaining. If you have any questions, definitely reach out to us on the forum. Trying to be on there more often and more active. So other than that, I'm just going to say bye. And I'm going to do the whole awkward ending thing again, where I'm just kind of staring at the screen, and then I go click on the end broadcast button. And then I click it again because it didn't actually end at the